Hi everyone, good morning. Today again we are going to discuss about hybridization only. We discuss about the postulates of hybridization, and in the live section also we discuss about that. So now we are going to discuss few more examples of hybridizations. Okay, so that's very easy. Just understand how we will do the hybridizations of C2H6. Okay, so I'm going to write it, how to write C2H6. C2H6, we can simply write it as CH3. Okay, in organic chapter, we will learn in detail how we are writing it like this. Okay, and understand all these bonds I am showing CH3. Okay, CH3. These are the bonds I am showing. Okay, now let us see the hybridization here, how it will come. So here, look at these two parts. These two parts are similar, right? Oh, each carbon is attached with a hydrogen atom, 3 hydrogen atom and 1 carbon atom. Here also, this carbon is attached with the 3 hydrogen and 1 carbon atom, right? So both of these parts are same. Both of these parts are doing, carbon atom is doing hybridization. So if I explain one, that is similar to the second one also. So let us see this carbon. This is a central atom, right? So this carbon is atomic number is 6. So our first step is writing the electronic configuration 1s2, 2s2, 2p2, right? And after that, we will write orbital electronic configuration. This is called ground state electronic configuration. First, we will write ground state electronic configuration. So this is the ground state electronic configuration. Okay, 1, 2, right? One orbital is empty. Now we are doing the excited state electronic configuration. Excited state electronic configuration. What happened? One of this is not involved. Only these two are involved. This is the outer shell. So one of the electron will be just exciting to the higher level. This is the higher level. So we will get one electron in this 2s1 and here we will get 3 electrons 1 2 3. Okay, now what we will do, so this is the excited state electronic configuration. Next step is what I said, hybridization. Last we discussed in last video, we discussed all this. So this s orbital, this 2px 2py and 2pz orbital will intermix and we are getting sp2 hybridized orbital, sp3 hybridized orbital. What is the reason? 1s and 3p. 1s and 3p means sp3 hybridized orbital. So how many atomic orbitals are intermixing? 1 2 3 4 atomic orbitals. So we will get 4 sp3 hybridized orbitals, and these are the 4 sp3 hybridized orbital. 1 2 3 4 sp3. Okay, and what should be the shape? It is having a tetrahedral shape. And what should be the bond angle? 109.5 degree will be the bond angle. Okay, this is common for all sp3 hybridized orbitals. Now, look at this. We reached till there. That is, we found that it is having an sp3 hybrid, 4 sp3 hybridized orbitals. Now, hydrogen atom is there. Each is attached with 3 hydrogen atoms. So, if you take hydrogen atom, it is having 1s1 configuration. So this s orbital that is unhybridized, that will be bonding with these, which orbital? sp3 hybridized orbital 1 2 and this is the third one. Okay, sp3 hybridized. This will be overlapping with the hydrogen atom. Look at this, and the one electron present in this will be overlapping with the 1 electron present in sp3. Each sp3 contain 1 unpaired electron, right? So here also that will take place as sp3. Okay, here also as 1s sp3. Okay, 1s sp3 will bond, and now this one orbital is there, right? Now one orbital is there that has to bond. So look at this. This carbon is bonded with this carbon. So what I said, each carbon is having the same hybridization style. So it is also is having sp3 hybridized orbitals. Okay, it is also having sp3 hybridized. This also will be bonding with the 1s orbitals in the same way what I explained now, and it will be sharing its electron with the sp3 hybrid orbital. 1s orbital of hydrogen will be sharing its electron with the sp3 hybrid orbitals of the other carbon atom, right? So you have one orbital sp3 hybridized orbitals here, empty, not empty, half filled. Here also half filled. Now these two are overlapping. That is what showing here. See, look at this. This sp3 hybridized orbital is overlapping with this sp3 hybridized. So sp3, sp3. Okay. Two sp3 hybridized orbitals are overlapping here. And then you will get the next sigma. So all these are sigma bond. All these are head-on overlap. Okay. So this is the shape CH3 molecule. This is all having the sigma bond. And its shape, each carbon atom is having a tetrahedral shape. And each is having the bond angle 109.5. That is all about sp3 hybridization of a C2H6 molecule. Now let us see the sp3 hybridization of another molecule, that is C2H4. Okay, this is C2H4. So C2H4, usually we will write it like this: CH2 double bond. It is having a double bond. Okay, CH2. Okay, we will see how this double bond is possible. So this carbon atom is attached with two hydrogen. If you look at that, and there is a double bond, and this carbon atom is attached with the two hydrogen atom. So what do you understand by double bond? If there is a double bond, means one of that is a sigma bond and another one is a pi bond. If you take a triple bond, one among that is only sigma bond, the two other one is two pi bonds are present. Okay, that is what it means. So in this one is pi bond, confirmed. Okay, so now just like sp3 hybridization, how we did the same thing, I'm going to do here. These two carbon atom is having same attachment. This is having attachment with two hydrogen atom and a double bond with one carbon. The same thing for this carbon also. So when I explain one, you will understand the other one. Okay, so the carbon, we are writing the electronic configuration is 1s2, 2s2, 2p2. Okay, and now we are writing the ground state electronic configuration, the same thing only, but I am putting it in last only. I'm writing and the box 1, 2, 2p2. It is like this. Now let us see the excited state electronic configuration. In excited state electronic configuration, what happened? One of the electron will be exciting from here to this orbital. Okay. Now, what we need to see is how many sigma bonds are present here. 1, 2, 3 sigma bond. The other one is pi, I said. If double bond is there, 1 sigma and 1 pi. So we need only these three sigma bonds. So we need only 3 orbitals. If you need only 3 orbitals, 1, 2, 3, 3 atomic orbital only will intermix. These only will intermix. So the third one is not going to intermix. So this become unhybridized p orbital. This become unhybridized. It is not going to intermix. Only this 1s and 1s orbital and 2p orbital only is intermixing. So when they intermix, we will get 3sp2 hybridized orbitals. Okay, 3sp2 hybridized orbital. And this 3 orbital, we know already how the shape will be. Okay, it will be having this shape, trigonal planar shape. The shape will be trigonal planar and the bond angle should be 120 degree, and that will be bonded with how many hydrogen? 2 hydrogen, right? So 2 hydrogen is having 1s1 electronic configuration. So here this sp2 hybridized orbital will be intermixing with the 1s orbitals of hydrogen to get a pair of electron here, a sigma bond here it will form, and another sigma bond with 1s, okay, of hydrogen. And this sp2 hybridized will be overlapping with another carbon atom. This carbon atom is also having sp3 hybridized orbital, right? Similar geometry for this also. So it will be overlapping with the sp2 hybridized orbital of another adjacent carbon atom. And it is having again another 2 sp2 hybridized orbital that will be overlapping with the C hydrogen is there. So 1s orbital of hydrogen. So pairing of electron will take place. Here also 1s orbital pairing of electron. Okay. So now the question is, what is going to happening for this unhybridized orbital? That is empty there. So what is happening there? So that's an important question. Look at this. If suppose this is on the plane of the paper, this unhybridized orbital will be perpendicular to that. If this is the plane of the paper, Suppose this is the plane of the paper, it will be perpendicular like this. So the sigma bond will be in this plane. Okay, the sigma bond will form in this plane, but the pi bond will be like this. Okay, perpendicular to the sigma bond. Okay, so that is what here it is showing. This is the unhybridized 2p z orbital that is perpendicular to this sigma. Okay, all this plane. Okay, and that contain an unpaired electron. Both of this carbon atom is having an unhybridized orbital, p orbital. Its shape is dumbbell shape and it contain one electron, and that will sideway overlap will take place. Okay, like this sideway overlap. So we know that sideway overlap means what? Sideway overlap means pi bond formation, right? So pi bond formation happen between these unhybridized orbitals. That is why we are getting a pi bond here. Okay, and what will happen? It is having two lobe, right? So this electron is having a tendency to move to this lobe and this lobe, this lobe and this lobe. Same like that here also this electron will be moving from here to here, here to here. So continuously flipping, flipping, flipping. So what will happen? We cannot see a electron in up or down, but we can see an electron density up and down. Okay. So it is just like a sandwich. Okay. Two bread in between some vegetables we are putting, right? So the vegetables are like sigma bond is the vegetable and up and down to bread is like a pi bond. Okay, the pi bond is like the bread. So in between what sigma bond formed is like vegetables. Okay, in the sandwich. So up and down we will get a electron density. So easily available electron density we will get up and down. Understand? This is all about sp2 hybridization in C2H4. Learn what orbitals are hybridizing and what is unhybridized and bonding between what and what. This is 1s orbital and sp2 hybridized orbital, like that you have to tell. Okay, so the bond angle and shape is also very important. That's all. Okay, now the third one let us discuss, that is sp hybridization. So in sp hybridization, what is happening? This molecule is C2H2, sorry. This molecule is actually C2H2. C2H2 is the molecule. So if you take C2H2, I'll draw C2H2, how it will be coming? One carbon atom, another carbon atom. 10th grade you are learning, right? Organic chemistry. So you know triple bond, double bond formation, alkane, alkene, and alkyne. So this is alkyne. It is having a triple bond and one bond here with one hydrogen, one bond here. Because carbon is having valency for one hydrogen is only possible. The three bond are taken here for triple bond formation. Okay. If you have a triple bond, what I said, one should be a sigma bond and two should be pi bond. Okay. One should be sigma bond and two should be pi bond. So here you have actually two sigma bond possible. The two other are pi bond. Okay. Now let us move. This is again the case. These two cases are similar. So if I tell about this carbon atom, same structure for the other carbon atom also. So write the electronic configuration of carbon 1s2, 2s2, 2p2. Okay. Orbital electronic configuration. This is the one. And this is the ground state electronic configuration. Now let us see excited state electronic configuration. So it will be like one electron here. And then one electron, one excited. But how many we need? Two sigma bond we need here. So that what will happen? One S and this P only will overlap because we need only two hybridized orbitals. So S and P only. That is, this 2S will be overlapping with this 2P. And we will get two hybridized orbital. That is sp hybridized orbital. Two sp hybridized orbital we will be getting. So each carbon atom is having two sp hybridized orbital only. One sp here, one sp here. So now what happened here? This sp orbital will be overlapping this hydrogen, that is a 1s orbital. 1s orbital of this hydrogen. So overlapping take place here. And here it is overlapping with the carbon, right? So that is also having sp hybridization, this carbon, and that is overlapping with one hydrogen. So 1s orbital of the hydrogen, this sp. Okay, and it is having 180-degree bond angle. You know, sp hybridization means 180 degree, and its shape will be a linear shape. So what will happen to this unhybridized 2 orbital? Just like similar, like we have x, y, and a z axis. Suppose this is taking place in x axis, y and z axis, you can see 2p orbital, right? That 2p orbital will overlap with the p orbital of the adjacent carbon. That is also unhybridized. And you will get 2 pi bonds here by sideway overlap. Okay. And just like the before what I said, this after this overlap, the electron will be flipping from one p orbital to other, so that the electron density will be concentrating up and down. If you see, it will be like this. Okay, like a sandwich, we can see up and down. It will concentrate. That's all about sp2 sp hybridization. Okay. Now let us see the next case. That is the hybridization which involve d orbitals. Okay, the so many are there, some examples are there. This table you have to learn. If you have dsp2, that is one d orbital and one s orbital and two p orbital will be, if it is if it is one d and one s and two p orbitals will be overlapping, and then you are going to get a dsp2 hybridization, and the shape will be 2 3 4. Even then its shape should be a square planar shape. Okay, the opposite also we have sp3d, but the shape will be different, trigonal bipyramidal. Okay, sp3d hybridization is coming, then it is, that is, this is inner d orbital. Okay, here it is inner d orbital and outer s and p orbital. Here it is outer inner s and p orbital and outer d orbital. Like that, the hybridization is. And square pyramidal shape for sp3d2, you are using two d orbitals here, and octahedral for sp3d2 and d2sp3. Both, if it is coming octahedral only. Some examples are also given. Let us discuss. We are discussing in our syllabus only two. The first one is PCL, but you have to learn this and understand what are the shapes. One weight question may come. So formation of PCl5, sp3d hybridization we are seeing now. So phosphorus, let us see the ground state electronic configuration of phosphorus. Okay, it is already written here. The ground state electronic configuration of phosphorus, 3s, 3p, and 3d is empty orbital for phosphorus. Okay, now this s orbital, from this 3s orbital, this is ground state, now excited state. One electron is going to the d orbital. So now what will happen? We have 5 sigma bond right here. So we need 5 orbital as hybridized orbital. So that is why we are making it availability of 5 sp2s. Sorry, hybridized orbitals are needed here. That is why we are making it by doing excitation. Okay, we are doing excited state here. No, one electron from this ground state is exciting here. For what we are doing such a additional step in order to get a 5 hybridized orbital. We need 5 hybridized orbital for PCl5. PCl5 means 5 bonds are there. So here already only 3 unpaired electrons are there, and we need 5 unpaired electron also. So we are making it, okay, by exciting it, this one electron to the higher level. So if you excite to the higher level, you see 1 2 3 4 5 electrons are also unpaired electrons are also available. At the same time 5 hybridized orbital also we will get, because this sp and this 1d orbital will undergo hybridization, and we will get sp3d hybrid orbital. How many? 1 2 3 4 5 atomic orbitals. So 5 sp3d hybrid orbitals we will be getting. Okay, and that sp3d hybridized orbital, in the case of PCl5, what is happening? Cl, what is atomic? 17 is the atomic number. So 1s2, 2s2, 2p5. Sorry, 2p6 and 3s2, 3p5, right? So 3p5 means 3p5, how we can write? 1 2 3 4 5. So on 1p orbital is half filled. So this half filled orbital, this one electron will be giving to this hybridized orbital, sp hybridized. So sp5 are there. So 3 will be like this, okay, and 1 up and 1 down. We know that trigonal bipyramidal, okay, shape we are going to get. And here In these, each one you will get one unpaired electrons are there, and that will be bonding with the p orbitals. Okay, p orbitals of which chlorine atom. So p orbital, it will be this is also which type of a sigma bond will be forming here. Everywhere sigma bond will be forming. Here also sigma bond. Okay, here also sigma bond we will be getting everywhere. Okay, so the shape, in short, we are only drawing the shape like this. Okay, don't forget about the bond angle, because trigonal bipyramidal means one triangle and two pyramidal shape it is having. So 120 and 90 degree. Okay, and now this is okay triangle here. So inside the triangle, 120 is the bond angle, and outside you have 90 degree. What is the reason? Because it is up and down and perpendicular to this triangle, so 90 degree. And this is called a equatorial bonds, and this is called a axial bonds. Okay, axial bond will be longer. We discussed this before. What is the reason? Axial bond should be longer than the equatorial, because in the equatorial position more bond repulsion should be there. So in order to avoid that, it will be moving away, okay, from the equatorial position. So that is why it is longer. Okay, now the next one is SF6. SF6 is having sp3d2 hybridization. Okay, that means 6 orbitals are needed. SF6 means 6 bonds, so 6 hybridized orbital. So we need sp3d2. So sp3 means 4 orbitals here, and 2 orbitals here we are using. So as a total 6 atomic orbital and 6 hybridized orbital we will be getting. Let us see that also. So here the ground state electronic configuration of sulfur is there, right? So what is happening here? One of the electron from 3s and 3p is exciting to the higher level. So 2 orbitals. So from 3s and 3p, one of the electron is actually exciting to the 3d orbital, so that sp and these 2 orbital, d orbital will overlap, and we will get sp3d2 hybridization. Okay, and sp3d2 hybridization, if you have, how the orbital will be? The orbital will be one here, one here, one here, and one here. sp3, now 2 more orbitals, sp3d2 orbitals, one up and one down you will get. So this is one sp3d2, this is another sp3d2, this is another sp3d2, and this is another sp3d2. This is another sp3d2, and here sp3d2. So you get how many? 1, 2, 3, 4, 5, 6 sp3d2 hybrid orbitals you are getting. And fluorine atom 9, right? So 1s2, 2s2, 2p 5. 2p5 means the p orbitals contain one unpaired electron here. So that unhybridized p orbital is bonding here. Look here, a pair of electron is sharing. Okay, a pair of electron is sharing everywhere like this, and we will get a octahedral geometry for this. This is the geometry we are going to get. This is the geometry we are going to get. Okay, this is the geometry we are going to get, and this geometry, the bond angle is 90 degree. Everywhere the bond angle is 90 degree. Okay, so that's all for today. Thank you.